Okay, welcome back. So right now what I'm going to do is I'm going to go through the problems that I assigned in the previous video, starting with number 5. It says graph the function y equals 4 times 3 to the x. So let's do that. Whoops. Love that white. Okay. There we go. So let's go 4 times 3 to the x. Okay, so we know from our previous discussion that this number right here is going to tell me the y-intercept, so that's going to be up here at 4. And then this number here is what I am multiplying by each time, so this one's growing quick. So 4 times 3 is 12, so I'd be way up here at 12, and then the next one would be totally off the charts. Going this way, instead of multiplying by 3, I'm dividing by 3, so 4 divided by 3 is like 1 1/3. Divide that by 3, and then divide that by 3. So it's going to get close to the x-axis really quickly. That is beautiful. Nice job. Okay, so there is my graph. So what is the domain? The domain, as it has been for all the other ones, is all real numbers. The range is y is greater than 0. Number greater than 0, not equal to 0, because it never actually touches the x-axis. The intercept is where it crosses the y-axis. That's this guy right here. So the y-intercept is at 0, 4, and xo-intercept is non-existent. Never crosses that old x-axis. The asymptote is y equals 0, and the end behavior is as x approaches, this is awkward making these arrows, but as x approaches negative, negative infinity, oh, I got a mailbox there. How in the world did that happen? I wish I knew. I was trying to put a negative. Oh, okay. My negative symbol has turned into a mailbox. This could be a problem moving forward. Hang on just a second. All right, we're back. Changed to wingdings there somehow. Don't know why that happened. Anyway, as x approaches negative infinity, the y values, as we go to the left here, the y values approach 0, and as x approaches regular old infinity, I'll do a lesson all in wingdings, see what you guys can do with that. As x approaches infinity, y also approaches infinity. And again, you see that from looking at the graph. When we go this way, the graph gets closer and closer to 0. When we go this way, the graph goes up forever. Alright, so that's number 5. Number 7. Describe how the graph of that is different from the graph of that. Well, I'll tell you how these graphs are different. Just going to color spice things up here a little bit. It is shifted to the right 3. Okay? And that's because the minus 3 right here, we can think of that minus 3 since it's up there in the exponent as being in parentheses. So it does moves the graph to the left or the right, and does so in the opposite direction of the sign. So negative moves it to the positive. All right, next one. What value of a completes the equation blah 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 for the equation shown for the function shown below? Well, we talked about a being the A is the y-intercept, and so the y-intercept of that is 4, so we would need A equals 4 to make that graph a winner. Okay, number 13, describe how the graph of that compares to the graph of that. All right, so we got two things going this time. The first thing that we have going is that the graph, let's be specific here, the graph of g of x is shifted 1 unit to the left. And then we can also say that the graph of g of x is shifted 4 units down. And again, the 1 to the left comes from the plus 1 right here, and the 4 units down comes from the minus 4. Okay, so then these next 4 are the ones that we did in the lesson. So let's see if we can get these figured out. For number 14, the domain is all real nombres. The range of this one, since it's not moved up or down, is going to be our standard y is greater than 0. Let's do the y-intercept first. Well, let's do the x-intercept first. Let's switch things up. Plus, that's really easy. The x-intercept is none. Again, that's because the graph hasn't been moved up or down at all, so it will never cross the x-axis. The y-intercept is at 5, because a equals 5 for that function. So y-intercept is at 5. What else we got? Okay, and then I don't want to write out the end behavior, so I'm just going to tell you. The end behavior of that one would be as x approaches negative infinity, y approaches 0, and as x approaches positive infinity, y also approaches infinity. Okay? All right, how about 15, the domain? Oh, I think you probably have this all figured out by now. All real numbers. Yay! What about the range? The range is, again, since this has not been shifted up or down, y is greater than 0. The x-intercept is still none. And the y-intercept is going to be this a value right here. So in this case, that would be 0. And then 0.75. End behavior. Okay, so this one, we haven't really talked specifically about why these happen differently in these cases, but since this number is less than 1, the graph is going to be going down because we're going to be multiplying by 2/3 each time. So in this case, our end behavior is flipped. As x approaches negative infinity, this graph is going to be increasing, because as we move to the left, we're going to be multiplying by 3/2 instead of dividing by 2/3. So as x approaches negative infinity, y approaches infinity, and then as we go this way, as x approaches infinity, y is going to get closer and closer to 0. All right, let's see what we got going here for number 16. The domain, is once again all real numbers. Picking up on a pattern there. The range, since this has not been shifted up or down at all, is also our old friend. Y is greater than 0. The x-intercept is, wait for it, you guessed it, none. And the y-intercept is, in this case, 0, 4. This one is a decreasing function because this number is less than 1. So that means it's going to be going down here just like this one was. So that means the end behavior for number 16 will be as x approaches negative infinity, the graph is going up. And as x approaches positive infinity, the graph will be getting closer and closer to 0, y equals 0. Okay, well, I guess we'll just start a new text box down here. Stubborn about it. Then for number 17, the domain is all real numbers. The range is y is greater than 0. And the x-intercept is, you guessed it, none. And the y-intercept is, hopefully you'll also guess that one, set. All right, cruising right along. Number 23. Let's see, write a function that represents the exponential function after a vertical stretch of 6 and a reflection across the x-axis. So a vertical stretch of 6, I'm sure you all remember, that's a G, BT dubs, means that you have to multiply the whole thing by 6. I'm going to throw a 6 out in front there. So 6 times 2 to the x. That is our vertical stretch of 6. And then a reflection across the x-axis, this guy right here means that I have to put a negative in the very front. So negative 6 times 2 to the x. There's my reflection across the x-axis. Graph both functions. This would be where you guys would complain, do we have to do the graphs? Well, I don't really care. Okay, so our exponential function f of x equals 2 to the x crosses the x-axis at 2 and goes like that. Okay, and then if I'm reflecting it across the x-axis and stretching it by 6, that means we're going to look like this, but we're going to cross at negative 6, and we're going to be decreasing muchas faster. So this guy right here is g of x. Oops. And this little fellow right here is f of x. Okay, good stuff. 28. All right, the exponential function g of x equals 3 to the x minus 1 plus 6 is a transformation of the function f of x equals 3 to the x. That is true. Does each statement accurately describe how the graph of g of x compares to the graph of f of x? Well, I can see that this is going to be moved to the right 1 and up 6. So g of x is translated 6 units up. That's a yes. G of x is translated 6 units down. Obviously, no. G of x is translated 6 units to the right. Not a chance. G of x is translated 1 unit to the right. Yeah, even though this is negative, remember that we do the opposite thing. So that's a yes, which means it's not translated to the left. Okay, then the horizontal asymptote shifts 1 unit down. No, the horizontal asymptote would shift 6 units up. So liar, liar, pants on fire. That's these two things are the only ones that are correct. All right, then last one. Which of the functions defined below could be the one shown in the graph? Well, we got ourselves a y-intercept of negative 1. Oh, okay, but that's, none of these are negative 1, but we've got, they're all shifted down, not all of them, sorry. These two have been shifted down 3, so I'm going to say that this is a loser, and this is a loser. Then the question is, has the original graph been moved to the right one, or has it been moved to the left one? And so if we take a look at the asymptote here, you would expect that the graph would be, well, what's the best way to describe this? Let's just plug in a number. So if I plug in 0 to here, 0 minus 1 is negative 1. 2 to the negative 1 is 1 over 2 to the 1, which is 1/2. Half of 4 is 2, and 2 minus 3 is negative 1, so that fits. If I plug 0 into there, then 0 plus 1 is 1, 2 to the first is 2, 4 times 2 is 8, and 8 minus 3 is 5. So this one is a loser. That one is a winner. Okay? All right, so hopefully that helps. If you have watched this video, feel free to send me some feedback if there are mistakes that I made, if there are things that you would like for me to do differently. This is a new adventure for all of us, so we're going to just work together and make this happen. Okay, thanks. Hope you guys are doing great. Bye.